Okay. So, light comes from electron transitions, yes? Where does most of the light come from that, we experience, that we know, that, where does it all come from? Yeah, but where, right, but no, what's this? Yeah, it comes from atoms, yes, we know that. But a particular place in the universe that we get most of our light? Any idea where you might see more light? Where do you get most of your light from? The sun, yeah. That was painful. Yeah, the sun. Okay, good. So you have the sun, right? How fast does light travel? How fast does light travel?
Super fast.
Super fast.
Fastest thing.
3 times 10 to the 8 meters per second. Okay? We're going to do a little example. We're going to do a little calculation. Okay, so take out a calculator or something with a calculator. It's 93 million miles from the sun to the earth. And that's called 1 AU. That's called 1 AU. 1 AU. AU stands for astronomical unit. 1 astronomical unit is 93 million miles. Now, in Taka, you don't use miles. So I'm going to give you some things to help you. Okay? All right. We know 1 mile equals 1,600 meters. Right? How long does it take the light to go from the sun to Earth? How long does it take? So, what do I do? I know that velocity is distance. Velocity is distance over time, right? I know that, right? So I know that t, are we looking for time? How long does it take? How long does it take the light to go from the sun to the earth? So I know it's going to take what? Time. I need to do time, right? So what does time equal? Time equals distance over velocity, right? Yes? Yes? Multiply both sides by t, and I get vt. Multiply both sides by t, I get vt equals d, and then t equals d over v. Yes? Yes? Okay, so it's going to be 93 million. One more. Million miles, right? Divided by what?
9 trillion. No, not trillion.
9 times 10 to the 8th meters per second. Now, I want to make conversions, so I know that this is going to be d times 1 over v. What's the 1 over v mean? The reciprocal, right?
Yes.
So I'm going to say that this is going to be d times 1 over v, which equals 93 million, right? Miles divide or time, sorry. I think I may be going off am I going off the board?
No.
Alright, I'm still on it, but I don't have much room left. Times, what's the reciprocal of this? What's the reciprocal of that? What is it? Guys.
3 to 10 to the power.
Second over
Second.
3 times 10 to the 8 meters, isn't it?
Yes.
Right? You were thinking too much. Right? Right? Okay, so I want to say 93 million times 1 over, you know what, I'm making a complete mess of this, aren't I? So it's going to be 93 million miles times 1 second over 3 times 10 to the 8 meters. Right? Yes? Yes? Is going to equal the time, right? So now, I have to get rid of miles and meters, right? They have to cancel. So what do I have to do? If I change miles to meters, will that do it? You guys haven't done this kind of calculation much before, have you? Okay. So what do I do? I want to divide by miles, multiply by meters, right? So 1 mile, 1,600 meters, right? Yes? Right? Cancel. Now, and the meters canceled, didn't they? See that? What do I got to do? I want to do this in days. Well, it may not take that long. Let's leave it in seconds and then we'll see what happens. Okay. What is 93 million times 1,600 divided by 3 times 10 to the 8th? Do you know how to put 3 times 10 to the 8th into your calculator?
Yeah.
You do?
Wait.
1.4888%.
Let me see. May I see your calculator? Alright, let's see. Right, but you got to divide it. So it's going to be, may I do it again? Is that alright? 93, 123, 123 times 1,600 divided by 3. How do you do your exponents on this calculator? I don't see exponents. You know have exponents? Mode. I have no idea. So that's going to be 3 times 10. 3 times 10 to the 8th will be 300 million, right? You all right? All right. 496, is that correct?
Yes, sir.
I'm sure. How do you know if it's correct?
Sir, I look at
Is that what you got? Did you get that on your calculator?
yeah, no, sir, I checked that thing. This room.
How? Let's divide that by 60, and that'll give you the number of minutes. How do I do that? What's this, fractions? What kind of calculator is
Sir,
this?
ST. There's some more.
Hit what?
ST.
I can't find it. Oh. All right, 8.3. That sounds right. So 8.3 minutes. So 8.3 minutes. So it takes 8.3 minutes for light from the sun to get here. Now, how does the sun warm the earth? Does the sun warm the earth because it's hot or because it's bright?
Because it's
Does the sun warm the earth because it's hot or because it's bright?
because
Right. Look at the hot.
Well, if you were halfway between the sun and the earth, would you feel hot?
Yeah.
No, you wouldn't. Not really.
Huh?
It would be, yeah, it's cold out there.
I heard.
You know what the average temperature is in deep space? It's like 2 Kelvin. It's cold in space.
Yeah.
That's like negative 270 degrees Celsius. It's cold out there. It's cold, man. Cold, 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 cold. So why? So if it's cold out in space, how does the sun heat the earth? Well, the light from the sun hits the earth, and the earth absorbs light. And that's it. So, you ever try to walk on a dark road, black road in the middle of the day? Is it hot out on the road? The road's not hot? The black road's not hot?
Oh, yeah.
In the middle of the day? Of course it is. Okay? Well, what happens is this. This is what happens. This is what happens. Here's the earth. Here's the atmosphere. This is not drawn proportionally. Okay? All right. The sun comes in, right? The light comes in. It's a wave. Light's a wave, right? Now, is all of the light absorbed by the earth? No, some of it is though. Some of it's absorbed because you can see the earth from the moon. So obviously some is reflected, correct? But a lot of it's absorbed. And then, in other words, things get hot, right? And gives off heat. Do you know what heat is? You know what heat is? You ever think about what is heat?
Heat is very hot temperature.
Heat is light. Really?
Basically.
Yeah, heat. Radiant energy. In other words, look, it gives off longer wavelengths. See, this is heat. This is light. Right? Here's light. This is light. This is heat. You've heard of this before. Infrared radiation.
Yep.
You've heard of that? Longer. These are not drawn proportionally. Okay, I'm being a little bit weird, but this is all you have to know. Ready? Visible light has a short wavelength. Infrared has a longer wavelength. This wave bounces back. Doesn't go out. Some of it does, some of it does, some of it does, but a lot of it is called, you know what it's called? We did this before. The greenhouse effect. But what I'm trying to show you is that light can change. Light can change. Yes? It can change. In other words, even though it's in a later chapter, I'm going to talk about it because it talks about what is light. See, in chapter 7, they ask you what is light. In chapter 9, which is in this unit, they tell you what light is, but they should have told you back in chapter 7. Here's light. Okay? These are long wavelengths. These are radio waves. Right? These are microwaves. Right? This is infrared light. Infrared. This right here, very narrow. Very narrow band. red, orange, yellow, green, blue, and violet. It's visible light, right? Then you have ultraviolet light, okay? Then you have X-rays. Then you have gamma. Heavy radiation, nuclear radiation. Yeah? Yes? Yes?
Yes, sir.
Right? Okay. This is what I want to look at right here. That's what I want to look at right there. Okay? Yes? You okay? Ultraviolet, visible, infrared, visible. So is this low energy or high energy? Relative visible light. Look, now think carefully. Long wavelengths, right? Radio waves. What's higher energy? Radio waves or gamma rays? Which ones do you think? What's high energy? Radio or gamma radiation?
Gamma.
Nuclear radiation? Bah! Or radio waves?
Gamma.
Yeah, gamma rays are high energy. So, what has more energy here? Radio waves or gamma rays?
Radio.
What has more energy? You just said it.
Gamma.
Yeah, so this is low energy. Low energy, low energy. Low energy, high energy. Low energy, high energy. You get it? Low, high, low, high. You get it? Okay? Alright, now. So this is what I want to do. I want to look at it in here. Okay? Because there's going to be, what time is it?
It's
We have a good 10 minutes. Okay, you ready? No? You're not? You're not ready? Okay, look guys. There's two things. Incandescent and fluorescent. Turn to page 208, 209, guys. Come on. No. 208. You're way into your 300. 200. 208. 208. We're in chapter 7. 208. Come on, you can do it. 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 All right. Are you on the same page I'm on? 208?
Yes, sir.
You are?
That's not 208. That's this one.
You're on it now. How many people don't want to be here right now? Raise your hand. Me either. All right, so we gotta give me 5 minutes. We're gonna be cool. All right. All right. How do you spell incandescent?
I-N-C-A-N.
I didn't ask you how fast you can spell it. I-N. What is it? C-A-N.
D-E-S. C-E-N-T.
Right? Incandescent. Right? What's incandescent? Look at me. Don't look at the book. What does that mean? That's like it's a type of old-fashioned light bulb. We don't have them anymore. How do you spell fluorescent? How do you spell fluorescent? How do you spell fluorescent? It's right in front of you, girl. Floor, like flower.
R-E-S. C-S.
A C?
R-E-S.
R-E-S? C?
C-E-N-T.
Fluorescent. Okay? All right. What happens is this. Incandescence and fluorescence. This was an old-fashioned light bulb. It got so hot, it gave off light. Like the sun. This was literally like the sun. You could start a fire. I mean, it was so hot. It was only 5% efficient. Most of the energy was waste heat. If you touched it to try and change the bulb after it blew out and you didn't let it cool, you get second-degree burns on your hand. Very, 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 very hot. Have you ever seen an incandescent light bulb before? Oh, you still have? Okay. So, here we have, you ready? This is infrared, right? This is ultraviolet. Now, so the incandescent light is white light. Yes? It's white light. It's It's white hot, it turns to white light. Yes? Fluorescent bulbs are like these. They are bulbs that are filled with mercury vapor.
Like the LED lights.
Not really, but it's filled with mercury vapor, and you run an electric current through it, right? And you produce ultraviolet rays. Now the ultraviolet rays hits this white coating on the inside, and it turns it to white light. Okay? Ultraviolet light, dangerous. You can't, if that will cook your eyes, it will kill you. It will give you skin cancer. Terrible stuff. But the coating, the white coating, the powder coating on the inside of the bulb, changes the ultraviolet to white light. So this is visible light. This is visible. Right? This is fluorescence, going from ultraviolet to visible light. This is incandescence, going from heat to light. You get it? Two separate sources of light. Infrared, so hot. So in other words, it's an energy conversion. It goes from heat to light. It goes from infrared to light. That's incandescence. Fluorescence goes from ultraviolet to visible light. You get it? You get the difference? We'll do some more on Monday. Do we meet on Monday? Or Sunday, I mean.
No, Monday.
Monday, not till Monday? All right. So continue outlining. Yes? Have a great week. I'm getting an applause. Wow. I am impressed.